All right, here's number 3. Please make sure that you have done this yourself first. Okay, don't just copy this. All right, 624.08 grams of aluminum hydroxide reacts with 588.48 grams of sulfuric acid, H2SO4. Determine the mass of water that could be produced. Okay, all right, so if you look down here, I've already given you the equation. So we're going to start with 624.08 grams of aluminum hydroxide. Okay, and I need to turn everything into moles before I can use the BCA table. Okay, so again, I'm just going to cheat and use Google to find the molar mass because, yeah, it's fine. 78. 78 grams AlOH3. Okay, and then the other one is also given in grams, and that's the sulfuric acid, H2SO4. Okay, and that is going to be H2SO4, 98.08 grams H2SO4. Okay, so let's go ahead and calculate. 624.08 divided by 78. So this is going to be 8 moles. Okay, again, I made the numbers nice and simple, hopefully for all of these. 48 divided by 98.08 is going to be 6. Okay, all right, so let's go down and look at the equation. First thing is we need to balance it. Okay, so again, here goes the water again, which I want to think of as HOH, right, so that I can compare the other side. Okay, so here I see 3 OHs. So let's go ahead and try a 3 here, because that's going to be 3 OHs here. Okay, that's going to give me 3 hydrogens. Okay, and there's only 2 over here. All right, so already I can see this is going to be a little bit trickier, okay? Because I can't put anything here, because if I was going to put this, I would have to put like a 1.5, right? Times 2 would make 3, but that's not going to work, okay? Because you can't have that. All right, so let's go ahead and back this out. Okay, right? And I can see that that was going to cause a problem. So this is going to be HOH, all right? Okay, so let's say I did this way. Say I saw 2 hydrogens here. I could try a 2 here. Okay, but again, I'm going to have this 2 OHs and 3 OHs. So that's going to be a problem. Okay, but you keep seeing this 2-3 pattern show up. All right, and what that means is that means you're going to have to try to basically double everything. Okay, so instead of 3 OHs here, okay, I'm going to try to put a 2 out here. So now I'll have 6 OHs, and then I'll try a 6 over here. We can always reduce it at the end if it doesn't work, okay? So now I'm going to have 6 OHs, and I have 6 hydrogens, okay? And here I have 2, so that's going to get a 3. So now I have 6 hydrogens, okay? Then I have 3 SO4s. Here I have 3 SO4s, 2 aluminums, and 2 aluminums here, okay? So this is actually going to be a 2, 3, 1, 6. All right, that was a little bit trickier to balance. Okay, all right, so I'm going to start with 8 moles of aluminum hydroxide and 6 moles of sulfuric acid, and then nothing in my products. Okay, all right, now it's time to choose who the limiting reactant's going to be. So in my recipe, I can see for every 2 aluminum hydroxides, I need 3 sulfuric acids, okay? So I need more sulfuric acid. And look down here, I don't even have more. Even if the ratios aren't perfect, I don't even have more. And I know 2 to 3, I'm going to have more of this. Okay, so I already know for sure that that's going to be the limiting reactant. Okay, because I don't even have more, let alone if the ratio is even right. Okay, so I'm going to go ahead and put my ratios in for everybody. Okay, all right, my given goes on the bottom. So that's 3, right, because this is my given. All right, and then I'll go ahead and pull these ratios down. 2, 1, or sorry, coefficients, 6. Okay, all right, so 6 times 2/3, all right, is going to be -4. All right, 8 minus 4 means I'm going to have 4 moles of aluminum hydroxide left over. All right, 6 times 1/3 is 2. So that means I'm going to have 2 moles of aluminum sulfate, right? Half as much, see, because here 2 became 1, right? So I'm going to need 4. Well, I guess I could have done this way. 3 became 1, so I need 1/3. So 6, I'm only going to get 2, okay? And then here, 6 times 6/3 is actually 12. So I'm going to get 12 moles of water, okay? Because here, 3 to 6 was a doubling. 6 to 12 is a doubling, okay? All right, type of reaction. This should be a double replacement because, again, it's 2 ionic compounds to start with, and they're switching partners, okay? Word equation, 8 moles of, make sure you use the names, okay, and not the symbols. Hydroxide react with 6 moles of, I'm just going to go ahead and call it sulfuric acid because that was given, okay, to form 2 moles of aluminum sulfate and 12 moles of water. That's a lot. Okay, remember we want to add our excess in here now, so I'm going to say 4 moles of aluminum hydroxide remain, or are left over. Okay? All right, let's see what the actual final answer is. Okay, the mass of water that could be produced. All right, so I can see that I had gotten 12 moles of water at the end. So now I'm just going to do this. 18.02, I think, is water, right? Okay, so 12 times 18.02, oops, 12 times 18.02 to 16.24 grams of water. That's my final answer. All right, that's number 3.